Welcome, everyone. Wes and I were discussing before this episode how passionate we are about the importance of the models that we're going to introduce to you in this episode. We're talking about the TCP/IP model and the OSI model. You may have heard of your colleagues or peers lamenting having to study this and just being like, oh my gosh, why am I being tortured with these models? But trust me, again, Wes and I were just discussing how critical this is for your career. So with no further ado, let's have Wes Bryan guide us through these important networking models.
I was going to say, you were doing my internal monologue as a student when it come to these topics too. You know, I was thinking the same thing. Why are we learning what we hear? We hear our conceptual frameworks. Well, conceptually, it's important to understand for networking. So that's why we're going to go ahead and talk about it. And these models are important because what it does is it helps us to have a standardized approach to networking communications. And what I'm going to go ahead and do is I'm going to start this one out with what's known as the Open Systems Interconnection Model. Believe it or not, like Anthony was saying when we were talking, it is actually the later model. TCP/IP has been around a lot longer than OSI. OSI came around in, I believe, 1984 by the International Organization of Standardization. ARPANET came out in 1972. Just to kind of give you a time frame, and at that time, before it was ever called TCP/IP model, what we were talking about was called the DoD model. So it actually has been out a lot longer, but to me, it's not as convoluted as sometimes the OSI model. It's very, very focused in its approach, and that's what I like about that model. So what I'm going to do here is I'm going to go ahead, and I told Anthony, I think we should start out with the 7-layer model known as the Open System Internet Connection Model, developed by the International Organization of Standardization, and it's a layered framework going from the top of the stack, as you may hear, layer 7, all the way down 7 layers to the bottom of the stack, as you might hear it called, the physical layer. And we're going to talk about each one of these and kind of give you an idea what's going on when it comes to standardized network communications.
So I suppose one of the first things I would want to do as a student, Wes, here is memorize these 7 layers. And the great news is there's 2 common ways we like to do this. You can start from the bottom, layer 1, and go up to layer 7, the top layer, with a mnemonic device. And if you want to do that, the popular mnemonic device is, please do not throw sausage pizza away. We have the physical, data link, network, transport, session, presentation, application layers. Again, you'll have notes on this, of course, to help you, but that's how we can remember it. There's also a top-down approach, and that is all people seem to need data processing. So one of the first things that we should do is use one of these 2 mnemonic approaches to memorizing these layers in their order.
I love those mnemonics.
Which one do you use, by the way?
I actually make them both pizza.
Oh.
So I use the same one, physical up,
pizza
but I do deep dish pizza instead of data processing.
I love
so it's all people seem to need deep dish pizza. And that's just because I like to eat pizza. So without further ado, let's go ahead and let's look at that top layer. And we're going to work from the bottom of the stack, the all people seem to need data processing, and we're going to work our way down. Now, it's important to understand what's happening at this application layer, all right? Because the only thing that we interact with as humans, really the user, is going to be the application layer. In fact, you hear jokes about the layer 8 issue. What sits over layer 7? Well, layer 8, that would be the user, right? So the little jokes like that. And the user directly interacts with the application layer. So what does the application layer do for us? Well, it really gives us access to the network services, right? And typically what we're going to do is we're going to be interacting with, to give you some examples, right? Email. We'll be interacting with things like the old POP3, SMTP. I know that's kind of gone by the wayside, but IMAP, right? Your web browsers, they actually operate at the application layer. You say, wait a second, what do you mean here? Well, hypertext, markup language, that's your data, right? In order to communicate and access the network with HTML, you have to do it over HTTP or securely HTTPS, right? So your web browsers, you interact with your web browser, you make a request to a web server, and it starts right there at that application layer, and it gives you access to the network services. It's not an exhaustive list. I would definitely, as you start to learn protocols, know where they're at. Because like Anthony was talking to me earlier, what is a layer 8 issue? Or not, well, we know what a layer 8 is. When's a layer 7 issue? What's a layer 3 issue, right? So it is important to understand where these operate. So application layer, right? We're talking about, Anthony, taking our data, our raw data, and now starting to give it access to the network services. We're not there yet, but right? That's the starting point.
And I love how in your diagram too, you show that layer 8 user interacting with this application layer. That's a great thing to think about. This is what we think of when we think of networking. We're in an email client. We're in a web browser. We are interfacing with that top layer, that application layer. And now, Wes, I suppose we're going to go down one layer beneath it. And I think we have the, let me get my mnemonic out here, all people. So this must be the presentation layer.
This is the presentation layer, sometimes generically called the syntax layer. Why? Well, I want you to think about it, right? If we start at the application layer, I want to write a letter, all right? But I want to mail that letter. Well, if I write a letter, I can't just take that letter and put it in a carrier system and expect it to go to the endpoint, well, whoever it's going to, right? I have to have it in a format first that it can be placed on that network. So how do we do that? Well, we take it and we put it in an envelope, right? Your presentation layer translates this information that's taken down into the from the application layer into the appropriate syntax for the network so that the network doesn't have to worry about it. Give you some examples. You know your image formats, JPEG, TIFF, GIF, GIF, depending on the the argument with the naming convention, right? That all happens right there at the presentation layer. Do you need to apply encryption? Right? Well, if you're going to apply encryption and compression, right, that's going to be something else. That's going to be a formatting of your data that will allow it to go out on the network, and the network doesn't have to even be aware of what that data is, right? So that presentation layer is really, really, I want you to keep that in mind, right? That's kind of like putting your letter into an envelope. What we're doing is we're getting it ready to be on the network, but it's not quite there yet. It has to be in a format that the network will recognize, but not really have to do anything with.
I love teaching with Wes. I've been teaching networking since 1996. So I've got over 25 years of teaching this. I have never heard the presentation called the syntax layer before. I sure wish I had 20 years ago because you can never forget it when you nickname it that.
Yeah, it's the syntax. I thought about it as the syntaxed and formatting layer or the translator for the network.
Love it.
Right. So now what are we doing? Now, I don't want to get too involved in this, but I want you to understand that each layer services the layer or provide, well, no, relies on the services of the layer below it. I have to make sure I say that right. So the application, I've got my data, but my data cannot go out over the network because it isn't in the right format. So it takes that data and it hands it to the presentation layer and says, I don't know. I don't know the format. You handle that. Right. Now, the presentation layer, it does its work, right? You will hear that these layers, they will provide services for the upper layers, right? So if you ever hear that, all right. So now we're going to do exactly. I think I let the cat out of the bag. I was going to see if you knew your mnemonic there, but yeah, I let the cat.
All people seem. So we're at the session layer.
The session layer. Okay. Anthony, let's talk about this. You know this very well, right? You know. So when we talk about the session layer, what we're talking about now is we're defining the characteristics of the communication, right? We're going to tie, like, what's the timing? You think about your session layers. I want to talk to Anthony, but before I talk to Anthony, I have to go out there and say, hey, Anthony, a handshake. I need to talk to you, right? So the session layer is responsible for setting up the communication, defining what those parameters are, and that's really important when we look at that, right? When we look at the session layer, it manages the dialogues, it handles the timing, it handles the dial. You might hear dial control. Are we using full duplex? Or are we using half duplex? Right? We need to make those decisions prior. So the session layer helps to establish the parameters of the communication, bring up the communication, maintain the communication, and then terminate the session when it's no longer needed. Now, why is that so important? Well, if we don't terminate the sessions, we can get denial of service attacks because we just sit there and memory grows and we're not using it, right? So the session layer says, oh, you don't need those resources anymore. Session's done. So the session layer is very, very important, right? This is where we are going to determine things ahead of time, right? Do we need, what timing do we need? What are those synchronizations? And again, maintaining that connection for us.
I think back to a previous episode where we were discussing standards. And of course, the standards bodies give us a lot of the workings that are going on this session layer. The session layer is not one that Wes and I deal with a lot because standards have dictated how the session layer is going to work. So there tends not to be a lot of troubleshooting here for Wes and I. Just knowledge of this kind of step in the journey is important. So yeah, session layer can be tough even sometimes to talk about, just because, again, a lot of this is just baked into the networking equipment thanks to standards.
Most definitely. So when we look at the session layer, right, remember, we have now determined what the call settings, or what are the communication settings going to be. But now we've got to do something a little bit more, right? So those services get passed down to what's known as the transport layer. And we look at the transport layer is very, very important, because what it does, the transport layer is where, if you want to go back to the envelope analogy, right? We've got our envelope. Now we got to figure out, do we want delivery confirmation on that mail? Or do we want best effort delivery? Let me give you an example here in the States. Might not actually translate to some of the European nations when you talk about your carriers. So for me, if I go into the United States Postal Service and I need to know that mail, that envelope was delivered, I say, hey, I want delivery confirmation and return receipt. And that lets me know that when I send that mail over that United States Postal Service and it goes to Anthony, I'm going to know. They're going to say, not technically, but they're going to say, hey, your delivery, it's confirmed, it's there, Anthony got it, right? Or am I going to say, yeah, I can probably get to Anthony in a couple of days. I'm going to go find the blue mailbox. I'll just throw it in the mailbox. I'm not going to sit by that mailbox and wait for that mail carrier at 5 o'clock to pick up that mail and give me a return receipt and tell me that I'm going to wait at this mailbox for you to tell me that was delivered, right? Doesn't work that way. That's what's called best effort delivery. And we have two options in this area. We have something known as transmission control protocol, which is a connection-oriented, reliable protocol that will ensure that we have reliable delivery. And if something's not right, it will take care of it. Your delivery confirmation with return receipt. UDP, on the other hand, is a lot faster, more stripped down, simplistic protocol, but doesn't give reliability. That's like no delivery confirmation. That's the best effort delivery, right? Now, we had a long conversation with this. It doesn't mean that you can't stack services on top of it that do provide reliability. UDP at the transport layer doesn't care. So this is where we need to tell, again, back to the envelope and the mail analogy, hey, I need delivery confirmation. I need to use TCP. I need reliable delivery, or best ever delivery. I'm just going to the mailbox, UDP.
I love it. And it explains a question that so many of us have when we first start studying this. You look at the transport layer and you see TCP, which is reliable delivery, and then UDP is the alternative, unreliable delivery. I immediately, when I first saw that, said, my goodness, I would never use UDP. I don't want unreliable network communications. But as Wes pointed out, there are ways to send traffic using UDP and build the reliability in the upper layers of the OSI model, particularly the application layer. So
most definitely. And let me explain some of the visuals here that I have too, because they might be a little bit abstract, right? It ensures that you have reliable end-to-end communication, right? So the little arrows there, right? If your connection breaks, right? The link of your connection breaks. Guess what? TCP can maintain and reestablish that connection, right? That's also assisted on that session layer too. It can do things like flow control, right? The other thing that it can do too, and the last one, the little puzzle pieces, is what if I'm missing a piece of the puzzle? What if TCP, reliable delivery, sorry, missed that data packet. Well, what happens? I need reliable delivery. TCP says, hold on a second. I was expecting packet 4. You sent me packet 5. I'm going to ignore packet 5. Can you resend 4? I need that, or this information is not going to be rebuilt in the right order. So I kind of want to explain some of the visualizations I had here if they didn't make sense.
I love it. So we are all people. Wait a minute. I'm starting at the top.
All people seem to
need. Thank you. Now I'm getting confused. Are we going top, bottom? So all people seem to, we are at the end now. We are at the need, and that is my favorite layer. It's the network layer.
That is absolutely correct, Anthony. Yep. So we're talking about layer 4. And what I want you to see here is maybe it's not, maybe you haven't caught it yet. Notice how what I have at the layer 3, just under layer 3, is the layer 4 data that's being received. All right. Layer 4 doesn't have to know anything about routing, doesn't care about routing. It's done its job, and it's going to hand it to networking. And the networking layer is going to say, all right, I really care about the destination address. Source address is important, but I really care about the destination address. And I need to now look at this database that I maintain in a router. I guess I should say a router would do this. And I can now see the best path to send that information. All right, so I want you to know that at the network layer, this is where we start to talk about IP addressing. Now we have our envelope, and we have a mailing address, and we have a return address. All right, that's important, right? And the routers operate at this layer, right? They also know what the source and destination of the address is. They can make, at layer 3, routing decisions are made, right? I've got a destination address. I've got this table. What is the easiest and best path to get it where it needs to go? All of those decisions are being made at layer 3. So Anthony, I run with this, but this is your bread and butter.
Yeah. This is, when I say it's my favorite layer, it's just that I work so often and teach so often the protocols that live here, like IP addressing and IP routing protocols like OSPF and ISIS and EIGRP and all of this great technology at layer 3. Something that Wes has just pointed out, by the way, and I should have maybe brought this up when I was talking about the mnemonic devices, is another thing that we should become comfortable with is knowing the layers by number. So in a lot of IT environments, you won't hear an engineer say, oh, it's a network layer issue. You'll hear them say it's a layer 3 issue. So it is handy to know these layers of the OSI model, both by name and by number.
And let me give you another example, because it threw me off the first as a student. What the heck is a layer 3 switch?
Yeah.
You know, and we'll talk about that later. Not to confuse you. It's a switch that can operate at layer 3, just generically. Yep. But what does that mean?
Yep.
This will help out.
Yep. You just reminded me of another one.
Sure.
A layer 7 firewall.
Right.
What's a layer 7 firewall? Well, sure enough, it's a firewall that can look all the way up to the application layer inside a packet.
Also called next-gen firewalls. That's very smart. So let's go ahead, now that we've figured out where our destination IP address is and our network layers determine the best path to send that information, now we talk about maybe being at the carrier sorting facility within close to the same physical location. That's the data link layer. So now we come down to the data link layer, and I will tell you, this is one that they had to go back and they had to kind of explain a little bit more of the functionality, because you might be saying, well, wait a second. I see the data link. What's this data link layer? Well, the layer 2, if you will, is technically called, if I can get this back here, it's called the data link layer, but it's actually made up of 2 sub-layers. And I kind of put them at how they interact in between these layers. So you have the logical link control, and the logical link control is for things like connection establishment, things like flow control and error detection. Media access control, on the other hand, is exactly what it sounds like. It is an access control, the access control mechanism of the data link layer. There's other things too, but for instance, you'll learn about things like carrier sense multiple access collision detection, right? That's our Ethernet media access method. That's all handled here at the data link layer by the media access control layer. Things like carrier sense multiple access collision avoidance, the access method in wireless connections and wireless Wi-Fi more specifically, guess what? All of that's defined here. And Anthony, I think this is interesting. You know, we've talked about things like network standardization. This is where one of those IEEE standards comes in, right? That 802.2 layer for things like bridging, right?
Absolutely. And Another one that we'll be getting into detail in other episodes is 802.1q.
Oh,
The
yes,
important
absolutely.
tagging that we'll see is critical for networks today. So
Mhm.
it's really great to see those standards coming into play here.
Definitely. And this is where, and I go ahead and mention this now, right? We talked about the IP addressing, right? Well, what do we do here at the data link layer? Well, now I want you to understand that we're going on the same physical links. And now what we're using is hardware addresses. We're not using logical addresses. Logical addresses are at layer 3. And again, back to Anthony's statement, couldn't be more true. The logical addresses. What are we talking about? Well, I can tell it's layer 3 because I got to be careful saying physical. Hardware-based addresses, MAC addresses, they're going to operate at that layer 2. All right, this is where switches operate. This is where frames happen. All very, very important. But then we have a fully formatted frame that now has to be, what do we have to do with it from there? All right, what's that last layer there, Anthony?
I think we are at the deep dish pizza level here in your pizza version. So we're at the physical layer. We are down all the way at layer 1 now. That first layer, the physical layer.
Absolutely. So what we're doing now, ladies and gentlemen, is we are talking about the electrical characteristics and the electrical makeup of the network, right? At this point, what we're talking about is electrical impulses. We're talking about ones and zeros. We're talking about cabling. We're talking about the radiated energy. We're talking about are we using analog signals with encoding process, the encoding process, right? This is all the electrical makeups and the physical, tangible assets of our network sit within this layer.
So those are those 7 layers of the OSI model, so critically important. But as Wes alluded to earlier in this video, this was not the start. This was not the initial networking model. The initial networking model was the DoD, otherwise known as the TCP/IP model. Here to guide us through that is Wes.
Absolutely. When we look at the TCP/IP model, this actually started back in the earliest days of the internet, before it was called the Internet ARPANET, right? And it was the Department of Defense that basically got the contracts for I say military, they actually invented it, really didn't get the contracts. They were the ones that started it. Well, when it was essentially handed over to a public domain, we started getting public access to it. But in the early days, it was a closed network that only universities were on. So I want to take a time. The good thing about a TCP/IP network is it's a little bit more focused rather than a lot more abstract. Let me show you what I mean. It's a 4-layer model, and it's important to understand that a lot of the functionalities that we see across the first 3 layers, as 7 through, I know how numbers work, 6, are actually included inside of the entire functionality of the application layer, layer 4 of the OSI model. Now, I want to stop on something that I believe, if you happen to be taking an exam, I'm not sure if you are, that is exam-worthy material. Layer 3 of the TCP/IP model is not the same thing as layer 3 of the OSI model. They are 2 completely distinct things, all right? The layer 3 of the OSI model is the network layer, right? So be very careful. If you happen to be taking an exam, I don't know if you are, make sure you know the context of which layer's number they're asking you. All right, because here at layer 3 of the TCP/IP model, we have the transport layer. Now, the functionality is the same, right? We're going to be making our reliable delivery, right? Connection-oriented services. But then we have what's known as the internet layer. Now, the internet layer is layer 2 of TCP/IP, but a lot of the functionality is the network layer of the OSI model, right? This is where we get the routing, we get the IP addressing. And then the last layer, layer 1, is called the network interface layer, all right? And the network interface layer, it combines all of that functionality that we've talked about in the data link layer and the physical layer of the OSI model. So I would know some of how it's broken down. Remember, we have different protocols, we have different technologies that operate in these layers, but if you can see that we have the physical and electrical components here at the network interface layer, if we talk about MAC addresses and link establishment, all at the network interface layer of the TCP/IP model, you can see that this 4-layer model is highly, I would say, optimized for internet communications more so than just generically for all network communications.
Yeah, it's really neat. It's neat to see them side by side as you've done in this episode. And it's neat to see how the OSI people, the ISO people, they said, okay, wait a minute, 4 layers isn't enough. We're going to break this down even more into 7 more generic layers that can apply to more than just a TCP IP setting. So it is really neat to see those initial 4 layers and then the 7 layers that resulted of the OSI model. Well, Wes, thank you so much for guiding us through these 2 very important models, both the TCP IP and the OSI model, that have been used for decades and decades in networking, and they're critically important. It's kind of the language of love that we speak when we are discussing networking topics. Thank you so much for joining us.